This is our last part of the notes. It's on page 8, percent composition. Now you're going to find the formula on table T, and I'm going to bring it in here. Table T, back page. Percent composition is the fourth one down. It's right here. I want you to find it in your notes. Write it into your note packet. Now percent composition is by mass. So we're going to be using a lot of numbers off the reference table. And we have mass of the part over mass of the whole. And we're going to use different variations of this throughout the year. And it's a percent, so we're going to multiply it by 100%. It should never be less than or a negative for this, as you'll see with some of the practice problems. So, the example, determine the percent composition by mass of each element. Well, the first thing that we have to do is we have to determine the gram formula mass. There are 2 hydrogens, each at 1.00794. And then we've got 1 oxygen at 15.9994. And as a reminder, we don't round. When we get to the end, we'll round to about the 10th for our final answer. So our GFM of water is 18.01528 grams per mole. So now we're going to do percent hydrogen. Now as we can see, mass of the part. Mass of the part is going to be the amount of hydrogen we have. So our hydrogen has a mass of 2.01588. In this case, the mass of the whole is the GFM, 18.01528, multiplied by 100. Now when you put that into your calculator and round to the 10th, our percent hydrogen is 11.2%. Now it says for each element, so we're going to do the same thing for oxygen, percent oxygen. And our oxygen has a mass of 15.9994. So those of you who have been setting it up this way, we're using these numbers right here for our mass of the part. 18.01528 times 100. So our percent oxygen is 88.8%. These numbers should add up to approximately 100% because we have calculated the entire percent composition. Now I want you to try the same thing for K2CrO4.